At this part, we're going to introduce wireless AEs. And firstly, as you can see in the figure, is about PoE switch. PoE switches provide power for connected terminals, such as APs, using the network cable. Makes it more convenient to supply power for this kind of equipment. And a PoE switch is a regular network switch that have the PoE functionality integrated. Except the PoE switch, next is antenna. Antenna converts high-frequency electromagnetic power into electromagnetic waves when it sends out signals. For example, for the transmitter, when it sends out signals, it converts the high-frequency electromagnetic power into the electromagnetic waves. And for the receiver, right, it converts the electromagnetic waves into the high-frequency electromagnetic power, right? This is about antenna. And antenna have multiple parameters. For example, the working frequency, the directivity, the gain, polarization direction, and the beam waves. Let's see them one by one. First is directivity. Antennas can be classified by the directivity as follows. First type is called the omnidirectional antenna. It radiates equally in all directions on the horizontal plane. In our daily life, you could see some antennas just like this. This is omnidirectional antenna. And except that, another is called directional antenna that radiates differently in the directions on the horizontal plane. So if you use a directional antenna, you can find the power strength on a specific direction is much higher. Okay, and they are suitable for different application scenarios. Firstly, let's see the omnidirectional antenna. Since it radiates equally in all directions, so you can see in this figure, no matter in the horizontal plane or the vertical plane, is equally, right? This is radiation in the vertical plane, and the figure 3 is a radiation in the horizontal plane. In mobile communication systems, cost-effective omnidirectional antennas are used in suburbs because they cover a large area. Of course, compared with in the downtown or in the city, users in the suburbs are not that centralized, so the antenna we use in suburbs should cover a large area and are applicable to short distance communication. While compared with that, the directional antenna, you can see, radiates differently in the directions on the horizontal plane. In communication system, directional antennas apply to long distance communication in a small area with higher user density and frequency usage. And actually, you can find the difference between the omnidirectional antenna and the directional antenna is that here we have a reflect board. These reflect boards are used to reflect the signals. For example, normally it's omnidirectional antenna, but all the signals to, for example, to the left are reflected by the boards. You can see are reflected. This is reflected. So we can reflect all the signals to a specific direction. Okay, this is about the directional antenna. And the next parameter is called gain. Antenna gain is an antenna's ability to transmit and receive signals from a certain direction. Gain is the ratio of the maximum radiation strength in a direction and the maximum radiation strength of an antenna, also known as antenna power amplification rates. Gain has implications for an antenna's radiation and ability to receive signals. Under the same condition, the greater the gain, the longer the distance away the signal transfers. This is very important. Gain is inversely proportional to the wireless bandwidth. That is, the higher the gain, the narrower the bandwidth. So again, not just have the relationship with the transmission distance, it also have the relationship with the bandwidth. Therefore, antennas with high gains are suitable for long distance transmission, while antennas with low gains are suitable for wireless signals in a large area. Because lower gains represents higher bandwidth. Increasing antenna gain extends the coverage of signals in a specified direction or amplifies the signals in a specified area. For a signal antenna, the easiest way to increase the gain is to reduce the angle or narrow the beam width. So here we have mentioned another parameter which is called beam width, and this is what we are going to introduce next. In this figure, it shows us the relationship between gain and beam width. And we can find that with the increase of the beam width, no matter in the vertical plane or in the horizontal plane, the gain reduce, right? The gain will reduce with the increasing of the beam width. And next is about the polarization direction. The polarization direction of an antenna is a direction of the electric field where the electromagnetic waves are formed. For example, the first type is called the vertical polarization. You can see this is the direction of the polarization. And the next is horizontal polarization, which is in this way. This is called the horizontal polarization. And next is the beam width. The half-power beam width is the angle from which half of the antenna's power radiates, or less than the maximum value of 3 dB. And here you can find on the left, the angle here between the 3 dB is 60, right? It's 60, while on the right, it is 15. So different signals have different beam widths. And here we just need to know how to figure out the beam width value. Okay, and another AE is called the arrestor, and it's actually used to protect APs. Arrestors are used to prevent current of thunder flows back to the AP, so we can protect APs. And it shows us two different types. First is 2.4 gigahertz feeder arrestor, and another is 5.8 gigahertz feeder arrestor. Okay, they are suitable for different hertz for different networks. And we just need to know that the function of it is to prevent APs from being destroyed by the thunder. Okay. And since we have introduced so many wireless AEs, so here we have a question. The question is, increasing antenna gain increases the rate of data transmission. We have mentioned that the antenna gain is related to the distance of signal, but we didn't say that it's related to the rate of data transmission, because the rate of data transmission is affected by many parameters. So we think this statement is false, which should be. Okay, that's all for this part.